Okay, BFD followers, we are in the progress of setting up our jig now to receive our tubes that will then let us tack our tubes in place and then proceed to complete the welding. What I'm going to do now is just go through and explain the jig setup. And of course there are different types of jigs, but I have a Z jig. There are other ones that are more like an L, and then there's the Sputnik jig that is like a big plate with these standoffs that you rig and do. It's kind of like doing a your build off of a table with offsets. Anyway, I'm going to show you my setup and explain a couple of the terms and things to look out for. Okay, so when you look at the drawing, it's going to have a couple features on there that are going to be used to set your jig up. And that's your head tube angle that is controlled by this assembly right here. Your seat tube angle is controlled here. And then your bottom, not your bottom bracket per se, depending on the jig that you have, but I'm just going to call it your drops. So it's a relationship between your bottom bracket down here and your chainstay, which I removed my chainstay mount for right now because I'm not going to use it until we get to the chainstays. Okay. So there's the dimensions for your seat tube angle and your head tube angle, and then there's what's called the rise and the run, and that sets the basic geometry of your frame on how it's going to ride. And since I'm going to be using a fork that is 160 millimeters of travel, so it's going to be a big hit bike, I have to raise the head tube up, and that gives me my rise. Okay, and that also affects your standover height and all that stuff. But when I did my calculations with the drawing, I had to have a 21.97 rise or something like that. I'll look it up here in a minute because it's crucial. So the other one is your reach, and that is the distance from the head tube to center line of the bottom bracket. It's a vertical 90-degree relationship, and that determines your reach. Okay, and so you need to know those numbers in order to set the distance for your head tube assembly, and then of course the head tube angle. Okay, so you can get an idea of exactly what you're looking for. Is I'm going to adjust the reach, and on my jig again I have an L shape or Z shaped, and so let me zoom out here, get a better picture of it. So the Z angle, right, and some might be an L, and depending on how your jig is set up and how it's used, will affect how you actually do it. In my case, the bottom bracket is fixed. It doesn't go up and down, forward and aft. It stays in one location. So others, you might have to raise and drop the bottom bracket. If you had a jig that was an L, it would have to move back and forth and up and down because your head tube assembly rides on a vertical axis, and that's all it has is a vertical and angularity. And so in order to get the correct reach, or not reach, but rise, you have to be able to raise the bottom bracket up and down with a relationship. I chose to do it differently. I fixed the bottom bracket and then move everything about it. Okay, so on mine, I wrote this down on the board up there so that I'd have a quick reference, is from the center line, which represents the center line down to the bottom bracket, comes up, right, to the center line right there. And then I come over and I move this assembly over until the bottom, to the bottom of the tube assembly is approximately 17.9 inches, and that's pretty damn close. I'd probably maybe say it's 18 inches plus or minus, but it all falls within my tolerance band. So again, you have to make a decision on how tight your tolerance band is. Okay, and so that checks out. Now, if you haven't put marks on your assembly, head tube stock assembly, that tell you what the angle is, then you're going to have to use some sort of protractor or angle finder. And before I painted it, and it's pretty scuffed up already, I had it marked, but you can't see it, so I have to come out and use an angle finder. And if you look at that, I just push that up for mine and make sure it's flush against the stock there, and then flush down there, lock it in place. I don't know if you can see that. That's 64 degrees approximately. Let me check that. Okay, so that's where you check everything. When I looked at it with my glasses on, my bent up, broken glasses and everything, but when I checked it, it actually read 62.9 degrees. So that's too slack. And so I need to increase the head tube angle assembly. And so that's what I'm going to do. Now I'm just going to show you how I do it. I don't have it measured or anything, so I'll have to come back and make sure. But I'm just going to loosen up the clamp. Whoop, it moved back. And now I'm going to tap it forward. Oh, that's probably too much, but I'll go and check it. But that's how I do it. That's how my jig works. Okay, so I went back. Oops, sorry about that fast movement. It's like get you dizzy and all that stuff. But I went back and I did recheck it. I put the angle finder back on there, and it's almost dead nuts on 64 degrees. So that's what I want, and I'm happy with it. It might be like a fraction of a degree off, but that's what works. Again, I plus or minus 0.25 degree, quarter of a degree or so for my drawings. All right. So the next thing, just come right back, is doing the exact same thing with your seat tube angle. Now, because this section of the jig is straight, but my tube comes up like this and then kicks back. This angle, hang on, let me just go ahead and grab the tube. You can see has an angle on it. All right, so it's going to come up into the jig and sit, and this part of the jig or the tube. Let's see if I can get the stand in there. I really need to get this on a stand, my camera. Anyway, so you can see this part and down is close to 76 degrees, which is not too steep. You can have seat tubes that steep, but then that's going to affect your reach and everything too. So if you a big tall rider, you're going to have to push out the head tube assembly to accommodate that. All right, but so that's a 76 here, but this part is 72 degrees, and I've calculated from the top of the tube. So this is going to be like a 16-inch seat tube, and that's along the straight, not counting the curve, because that's all I care about is the distance from bottom to top in a straight line. And then I calculated an average rider for a medium-sized frame and went out to the top of the saddle and calculated that and moved that assembly to show 72, and that's where the top of the saddle peaks out. And so it's like having a moderate seat tube angle overall, if that makes sense. It's not super slack, it's not super steep either. It just works out for a person that's going to be close to 5'10", 5'11". All right. Okay, so my jig here for the seat tube is clamped here and pivots about the bottom bracket. And so again, like I said, the bottom bracket doesn't move. It stays fixed in the XYZ coordinate. And everything that for the frame adjustments is made off of point 0 or location 0. That'd be like a Cartesian location. But hey, let's not go there. So I have a clamp here, and it's clamped down here, but loose enough so that it still rotates. I loosen this point here and push the intercostal here, the beam, forward and back depending on what angle I want. And again, because I played around and redid my jig a bit, my numbers are off on here that I had. So I have to still use an angle finder. And so I come in here, push that up there, make sure everything's flush, come back and look at it, and .72 degrees. And that's exactly what I wanted. So I'd come in here and I would just take my Allen wrench and crank that down, make sure that it's not going to move around. And if my assembly was all set, tube-wise, I could actually come in here at this point and load the seat tube in there. And that would be Bob's your uncle there, right? So you can see what it looks like. So it's got the bend right here, and this section of the tube, if you were to measure it, is about 76 degrees, and then it kicks back and comes up to a point which is at 70, equates to 72 degrees. Actually not quite 72, but yeah. And there you go. Okay, so the last thing that I wanted to talk to you about dealing with the jig setup is that you need to make sure that you're consistent on how you do your measuring. Okay, so depending on your jig that you have, you need to make sure the relationship between the bottom bracket and the head tube assembly and your rear dropouts is the same methodology. What I mean by that is my bottom bracket is a fixed station, and so it's 0 in the coordinate system. So everything is based off of that. So my chainstay and rear dropouts have to go up and down depending on how big the bottom dropouts are to the bottom bracket, and that determines the bottom bracket height, along with, of course, your relationship to your fork and your wheel size. That pushes your head tube assembly up your jig, which is the rise that I talked about earlier, and then the rear dropouts, and the terminology that you'll hear is drop, and that is the difference between the bottom bracket and your dropouts. So typically, if you've got a 29er hardtail, you're looking at like 2.5 inch drop. So that would mean that I'd have to raise the rear dropouts up 2.5 inches in relationship to the bottom bracket, and that would give you a chainstay that would be like something like that, right? I'm exaggerating the angle just so you can see. And if this was like a road bike, or you might see something even steeper, 3 inches, depending on how slack you want it. 26 inch wheels and 27.5 inch wheels, you could actually see almost a neutral 0 to like a 1.5 drop differential. So you have to make sure that you make this adjustment, because as an example, I failed to do that on an order, and I actually made the frame, and it was built to a prior build, and the bottom bracket was too low, and it was like I think it was like almost a 10.5 inch bottom bracket. So you can do the math. If you have 7-inch cranks, you're basically dragging your heels when you ride. So don't make that mistake. I had to cut the chainstays off and redo the whole. Actually, I think I had to do the whole frame over just because of the relationships. But anyway, costly mistake. So make sure that you double check these measurements and your head tube angle measurements. Seat tube is pretty easy for me. This angle here is easy to derive and set up. I did say that I was going to show you one extra little add-on that I put on my jig just to make things easy, idiot proof. So I put this little L on here, and this distance here is the same distance up here. Right here. Excuse me. And that's just so that I know that when I'm doing my welding and assembling, disassembling things just to clean, that when I put it back into the jig, I can get this recentered without having to do any scribing onto the bottom bracket, onto the tubes. Because when you're welding, you're cleaning it all the time and you're removing markings. So by having this little doodad, it really does save me time on setup, and it idiot proofs it. So all I have to do is slide my tube back on, sandwich it in between the closeouts here, and I'm good. And this distance from here to here is the same as that distance from there to there, and that makes it really simple, much more professional looking than if it's off. Not to say that sometimes you might want this to be slightly off just because of the drive side needs more room. I've actually designed one where it was like a 16th, maybe a little more than a 16th inch longer on the drive side. That was just a special case. Anyway, there you go. That's the jig setup. When I start doing welding, as I go, I'll show what I'm doing in general and the relationship that you'll see the importance between up here to down here into the seat tube and then into the stays. Okay. Now, mitering, I'm pretty sure I covered that already. I know it wasn't a very good video, but I did talk about it. And let me just grab one of my tubes. Okay. So this is the down tube that I mitered, and this is the miter common to the bottom bracket. You can see it has several cuts into it so that it will accommodate the pass-through for the seat tube and then the bottom bracket. And then on the other end, it's mitered to sit up against the head tube. So here, I'll just drop it in there real quick so you can take a look at it. I don't know how many times I've dropped this tube just because I didn't have it sitting in there right. But you can see how that sits in there. And you see that gap underneath there? That was something I need to clean up. And the way I do that is I need to make some minor cuts in the bottom bracket area. And maybe up here, I don't want to deal with that too much, but the interface there, it's definitely riding. And then that's going to affect the top. It's going to cause it to slide. But you can see I still have a gap, a little gap up on top, and that would account for my incomplete mitering of the down tube. So get those straight. Take your time on mitering. I'll try to throw in a link to a coping. By the way, it can be called coping, mitering, notching. You know, there's a whole bunch of ways to skin a cat. So there's a whole bunch of ways to say the same thing. Anyway, I'll try to drop a few links in on the video. If you use BikeCAD, I'm not sure if the free version has that mitering templates. It's really nice because you just put in you do your design, and then when you're ready, you can say, hey, give me the mitering templates, and you can print them out, and you can then tape them onto your tubes, and then you can use just a grinder or files or whatever and cut it down to the size, and it's pretty accurate as long as you get your jig set up correct. They should come out perfect. Okay. What I'm going to do next is I have to put my top tube, cut my top tube in, and cut it to length. I haven't mitered it yet either. And as you can see over here, I put in a breather hole. Don't forget to do that on your interfaces. You don't need one down here because you're going to cut one. You don't need one down here to come to the bottom bracket because the bottom bracket will have breather holes. So you have a vent at the top. Let the air expand as you're welding, and then you have venting down into your bottom bracket. So that's good. Your seat tube has venting down to your bottom bracket. That's good. Your top tube has venting here and here, and that's good. And then they function as drain holes too. So everything will drain down to your bottom bracket. And what I've been doing lately is I've actually been putting a single tap hole under the bottom that I can either plug with a small bolt or a tap screw, or leave it open and let the material drain out as it goes in. Your call. All right, so let's go and get that done and meet back here when we're ready to weld or tack weld everything into our frames. All right, best of luck. Talk later.